planet Earth.
So without further ado, climate under pressure.
What you're looking at isn't some alien world. This is here, on planet Earth. Extending beyond depths of 3,000 meters, the deep sea makes up half the ocean. Though it is a place we hardly know and almost never see, it is in fact the largest habitable space for life on Earth. And yet, with just over 20% of the seafloor mapped in any detail, only a tiny fraction of this incredible environment has been explored and studied. These animals and landscapes seem like the stuff of dreams. But in reality, these intricate and delicate systems play a vital role in sustaining life on Earth, and we are only just beginning to learn how vulnerable they are to climate change.
We humans have had an incredible impact on this space despite not being here, despite not doing a great job of exploring it.
The effects of a changing climate have already altered the deep sea and will continue to do so. Temperatures are estimated to rise by 1 degree Celsius in the deep ocean by 2100. It is almost certain to have harmful effects on organisms so finely tuned to survive in such environments. There are still countless undiscovered species dwelling in the abyss. Many of these organisms are so new to science that we are only just beginning to understand them, while others remain completely unknown.
Every time we go down into the deep ocean, we discover something new. There's something we haven't seen. There's a new species, a totally new type of habitat. There's nothing like that feeling and that excitement of looking at something that you know is new and trying to figure out how this new piece of our planet works.
Compared to conducting research on land, the challenges for exploring the deep sea are immense. Exploration of this world has only just begun, thanks to advancements in technology in recent decades.
Okay, here we go. Launching in 3, 2, 1. Launch now.
The single greatest impediment to studying the deep ocean is that it's not as transparent as air. I can look up with my own eyes and see the surface of the moon 250,000 miles away, but I can't even see half a mile into the ocean. That's why we have to develop technologies that can act as our eyes and ears.
Nice.
Ocean scientists are working with engineers and innovators to overcome the challenges of deep sea exploration and to prove that understanding this ecosystem is not only possible, but essential. We're developing exciting new technologies for oceanographic exploration, which feed us valuable information on the current state of our oceans.
I mean, it's been more than a decade of development to get these pieces of equipment to the point that they're at, where you can go out and do an experiment like this. And it's sort of long-term investment that I think is going to transform how we do ocean science.
One of the most fascinating aspects of oceanography for me is the discovery, when we are looking for something. And the question is always, how do we find it?
From remotely operated and autonomous technology to listening devices and imaging systems, a staggering array of innovative equipment is now at our disposal. shining a light into the deep for the first time. And the wondrous things we've illuminated have captured the world's attention.
Every single time an ROV dive takes place, we see something amazing. We see something we weren't expecting to see. We see life in environments where we don't expect to see life. The ocean is full of surprises, and our exploration is so in its infancy.
As these submerged visions appear, we realize that for every natural wonder on dry land, there's countless more underwater waiting to be discovered.
I always find it amazing to think that no human eyes have actually looked at this piece of seafloor before.
Most of us recognize the Amazon rainforest. Yet in the depths of our oceans stand ancient coral forests, teeming with life and far less explored.
Just like we all know, you cut down the rainforest, a lot of important functions are lost that those rainforests provide, including potentially new medicines. And so the same kind of concepts apply here to the bottom of the ocean.
I've said this a few times today, it's not every day you find a 500-metre tall reef in the Great Barrier Reef.
New coral reefs are still being discovered, thanks to the high-resolution maps we do have. But how many more are still hidden from us? Contrasting with these ancient coral ecosystems are bubbling superheated vent systems that support organisms right out of science fiction. Imagine a place so dark, toxic, and hot that the very idea of life proliferating there would seem absurd.
Crazy hydrothermal rock full of noxious chemicals, arsenic and selenium, and it's potentially radioactive, and yet it is teeming with life. And that's just astonishing to me. And you think about what you can learn from studying something like that. It's a tremendous opportunity.
From crushing pressures to pitch black darkness, from inhospitable cold to superheated systems, deep sea organisms are masterfully evolved to survive in places we originally thought life could not possibly exist.
There's all kinds of challenges living in an environment like this, yet life proliferates.
Until very recently, these alien worlds remained isolated from human impact. However, as we further our understanding of the deep, we are beginning to see just how vulnerable these environments are to the changes people are making to the planet.
It's devastating to see that impact on these ecosystems before we even fully understand them.
Everything on Earth is part of an interconnected system. Sea, air, land, and ice are linked by important life-sustaining processes.
Understanding what those processes are is incredibly important to how we understand how the climate of our planet works.
As we emit carbon dioxide into the atmosphere and our planet heats up, these processes shift and change. As the ocean warms, the conditions and patterns which sustain life are altered, and we may lose environments and species without knowing they ever existed.
We're the ones who are capable of having the greatest impact for good or for bad. You wouldn't go and build a house on land that you haven't surveyed, that you don't know what's under there. You wouldn't drink water that you haven't tested to see if it's clean or if it's poisonous. Studying the ocean in the way we're doing, and many others do, allows us to help us understand what our ocean is about, what it takes to keep it healthy, and how can we reap the greatest benefit from it through sustainable practices. How do we do the best job that we can of being the caretakers of our world?
From hydrothermal microbes used in the development of one of the first COVID drugs, to clinical trials using deep-sea compounds to treat lung cancer and Alzheimer's, there is an abundance of information in the ocean's depths that could be vital to our survival. And the deep may also hold solutions for mitigating the effects of climate change. The importance of understanding these environments is paramount.
By coming up with new ways to explore this largest inhabitable volume on our planet, we're essentially establishing a baseline, biologically speaking, of what's there, and then from there understand what changes we're making to it.
The future is hopeful, but there is still much more to discover, and so much that we still need to learn. Some deep-sea organisms are 4,000 years old, having started life when human beings were only just inventing how to write. Their environments have remained relatively stable for millennia. And now, we are accelerating change at an unprecedented rate. We must dive deep and look into these worlds beyond imagining to discover what is there, before they are lost forever. People from all around the world are working together to create the tools and methods to better uncover what lies hidden in these most inaccessible depths of the ocean.
We still have time to address this problem, to highlight and underscore ways to make things better, to change the way people think about things.
Through this vital work, we hope to unlock a profound understanding of our planet, our ecosystems, and ourselves. More than ever before, the deep sea needs us. And from the moment when life on Earth began, we need it too.
Thank you very much. For those of you that just came in and missed some of the video, we will be showing it again. You can look for that video at Schmidt Ocean, both online on our website and on our social media and through the live stream today. I never get tired of looking at those images, especially the glass octopus. And I'm looking forward to hearing more from our esteemed panel today about climate and the deep sea. So I'd like to start by introducing who we have with us today and remind our viewers in the audience today and online that you can participate in today's panel by submitting questions through Slido. So I believe the Slido code is behind me here. Please feel free to submit your questions throughout the panel today, and we'll try to address as many of them as we can. To the left of me, I have Dr. Jyotika Virmani, the Executive Director of Schmidt Ocean Institute. To her left is Professor Alex Rogers, the Science Director at Rev Ocean and Senior Research Fellow at Somerville College at the University of Oxford. And Mr. Jamie McMichael Phillips on the far end there. He is the Project Director for the Nippon Foundation JEBCO Seabed 2030. I would now like to give an opportunity to each of our panelists to share a little bit more about what they do and how their work connects to climate. We'll start with Dr. Virmani.
Thank you so much, and welcome to COP on the first day. I have to say, sitting down here, I think I'm getting an inkling of what it's like to be in the deep sea as I look up in this environment at all of you. So I'm Jyotika Virmani. I'm the Executive Director for the Schmidt Ocean Institute, and we have been established since 2009 when Eric and Wendy Schmidt set the institute up. We operate a research vessel, which is shown in this image here, the Falcor, and we take scientists and technology developers out to sea at no cost so that they can get out and do the research they need, do the exploration that they need, test the technologies. And we do that because in the recognition that it's been very expensive to get out to sea. And in exchange, we ask that they make their data and findings publicly available as quickly as possible, because the spirit of open data sharing really pushes forward our understanding in leaps and bounds. And once we have that understanding, action can be taken. And we all lived through this with the coronavirus, when data was shared, which has resulted in the fastest development of vaccines to date. So I'm going to take you through some slides here, which some of these you'll have seen the images on that lovely movie that we just watched. This is a siphonophore. This was discovered last year in April of 2020 in the Ningaloo Canyons off Australia, and it is the longest sea creature in the world. And it's an amazing image, amazing thing to capture on our ROV cameras, which I'll show you the ROV picture in a minute as well. But what's amazing to me is it was only in 2020 that this was discovered. Of all the years and centuries that we've been going to sea, we still don't know what's out there. It's huge. And what else is out there if this was just found last year? So this was taken with our ROV Sebastian, and that's shown in this image here. This is a robot that's tethered to our vessel. It can go down to 4,500 meters, and it has on board 4K video camera capabilities, as well as the ability to sample, bring back samples of life as well as rocks, and also to test technologies at sea. And actually, in the audience, I know we've got Alex who produced that video, but we also have in the audience our ROV manager, Errol, and also one of our wonderful crew members, Douglas. So it's really great that we're here in Scotland and they're able to join us. So this was also mentioned actually very briefly in that video, and this was the discovery last October, of a new coral reef on the Great Barrier Reef, again highlighting how important it is to explore the ocean. So most people think of the Great Barrier Reef and they think it's such an iconic feature, surely we know everything about it. Clearly we don't, because last October this 500-meter tall coral reef was discovered, and it's a pinnacle. It's on the ledge of the Great Barrier Reef. It was done through systematic mapping of the seafloor. And I think Jamie's going to talk about some of the importance of seabed mapping and what the discoveries are. This is 1.5 times as tall as the Shard in London. So it's a really tall feature, and because we had the ROV, we were able to dive on it and just get a sense of what it really looked like. And I'm happy to say that it's a wonderful, healthy, vibrant reef. And this was again last year at a time when there was, the Great Barrier Reef was under stress due to climate change. So it was really nice to see this reef and its life so vibrant. And then the following week, our cameras caught this serendipitous little creature. This is a ram's horn squid, and you may know or have seen the spiral shells maybe on the beaches or in museums and places. That shell is actually inside this creature. And this has been caught in the past in captivity. But the interesting thing is when it's in captivity, it swims the other way around. So the eye is actually downwards. So when we saw this, this was the first footage ever of this in the wild. And we are not squid experts. The scientists who are aboard are not squid experts. But we do live stream all of these dives. And we only realized the significance of this creature when social media started to pop up. And the squid experts were getting all excited because it swims the other way around in the wild. And that shows, that's quite literally turning the understanding of the scientists who study the squid community upside down. So it's a really remarkable thing to see that. And again, highlights how much we still have yet to discover as we explore the ocean. This, I don't know if you can see it, but in the center of this image is a 1 centimeter long pygmy seahorse. Can everyone see it? Oh, yeah, I see some hands pointing at it. Great. So what's remarkable about this image, I showed you the longest sea creature. It's a 45, which was the 45-meter siphonophore. This is a 1 centimeter sea creature, also caught with our cameras on ROV Sebastian. So the ROV is like a car, and the amazing thing about this image is it's like driving a car and seeing a safety pin on the pavement. That's how amazing it is to catch this imagery. And it shows how much we really rely and need the technology that we have at our fingertips. Let me just go back one. Okay, and then just to quickly wrap up, in addition to the exploration and the encouragement of technology development so that we can improve our understanding of the ocean and our exploration of the ocean, we actually also communicate about our findings, and you saw that in that magnificent movie we just watched, but also we have an Artist at Sea program, so that artists can come on board, they learn about the science, and they talk and communicate in whatever medium they choose to audiences around the world. And so I think we might talk about some more communication topics around this as well. But it's really important so that people know what the deep sea is, how important it is, how it connects to climate. And I'm just going to wrap up there with my favorite image from this year, which was the glass octopus. This was captured in the South Pacific, and it's a completely transparent creature. And what you see in there are its organs. And it's just, again, incredible footage. So thank you all. And thank you very much to our crew and our ROV team. And
just multi-purpose research vessels, which you can see a mock-up here of. The vessel is still in construction. And this is funded by the Norwegian billionaire Kjell Inge Rocker. And you can see here him photographed with our CEO, Nina Jensen, who has a background in working with NGOs in Norway. And RevOcean really are working to try and get a better understanding of the ocean so that we can actually carry out actions which really mitigate some of the negative impacts that we have on the ocean. In particular, we're interested in mitigation of climate change, but also sustainable fisheries, and dealing with the plastic pollution problem in the ocean, which, as you all know, has become something which is really, really ghastly. So moving on, I thought I'd start by saying that actually climate change has happened in the past. And this is something you will often hear climate skeptics say. But it has happened in the past, and what they often will not tell you is that climate change has often been associated with really massive extinctions in the ocean, and particularly in the deep ocean. And the reasons for this have been that many of these climate change episodes have been linked to disturbances in the carbon cycle, some of them, for example, produced by massive scale volcanic eruptions. And these have created a number of disturbances in the ocean, such as alterations in primary production at the ocean surface. And of course, it's the sinking of that primary production or food into the deep ocean that really powers many of these deep sea food webs that you've just seen some examples of some of the creatures that live down at these depths. But also climate change obviously changes temperature even in the deep sea. The ocean has absorbed something like 93% of the excess heat down to present climate change. So actually, moderating the warming effects on the atmosphere. But also it affects the oxygen content of seawater as well. And in some of these episodes in the past, the deep ocean has become completely deoxygenated, wiping out the deep sea fauna of the past. So this animal you see here, the nautilus, which is a living fossil, is actually quite a rare creature to survive through these episodes of past climate change to today. And of course, we also have other effects such as ocean acidification and the generation in some parts of the ocean of highly toxic hydrogen sulfide. Now, I do apologise for putting this diagram up after you've seen such lovely film footage, but I just want to point to the figure which you'll see there under intermediate and deep ocean. And you'll see there 37,100, and that is in fact 37,100 gigatons of carbon. The deep sea is the biggest active carbon store in the ocean, in the Earth system. So it does play a major role in terms of the carbon cycle on Earth at the present time. And we're discovering literally month by month of some of the roles that the deep sea plays in terms of regulating carbon dioxide in the atmosphere. And these are just a number of the newly discovered carbon pumps in the ocean. So these are active mechanisms which involve life, which move carbon into various stores in the ocean, including the deep sea. And in particular, I'd point to the one here, the twilight zone carbon, and this involves the active migration of animals from the deep sea up to the surface of the ocean every night, almost everywhere in the ocean. Those animals feed and then they dive down back into the deep sea every single day at dawn. And so they actually transport that carbon they fed upon into the deep sea. Now, a few years ago, the fish in this zone, we thought there were only about 1 billion tonnes. And then some clever scientists in Norway had the idea of running echo sounders over the nets that we use to sample these fish, and discovered that 90% of the fish swim out of the way of the nets. So we'd underestimated the biomass of these fish by an order of magnitude. So there's something like 10 to 15 billion tonnes of these animals actively transporting carbon every day. Climate is having other effects now on the deep ocean. For example, to power the renewable energy solution, some people think that it's now a good idea to actually go and mine some of the metals that are needed for batteries and so on in the deep ocean. So scientists are playing a really fast catch-up on what actually lives in these zones they intend to mine. And just literally over the past few years, there's been a lot of focus in an area called the Clarion-Clipperton Fracture Zone in the equatorial Eastern Pacific. And recent work is showing us that this area is much richer in life than we ever actually dreamed, but also that that life is not equally distributed across the CCFZ, and in fact you get different communities of animals living on, for example, the seamounts and hills in this zone compared to the flatter areas, which are all covered in these manganese nodules, which are rich in metals, which people want to mine. And some recent work has also modelled what would happen if we removed these manganese nodules from these deep sea ecosystems. And that work suggests that we would lose something like 1/5 of the species and something like 1/3 of the interactions between species at these depths. So we're learning more and more all the time, but it's still the case that we've only described about 10% of the species in the ocean. And obviously when you get into the deep ocean, then the proportion of species we know is much less. This is another idea about trying to pull carbon dioxide from the atmosphere into the deep sea, and that is to grow seaweed at huge scales, and we're talking about thousands and even millions of tons, and then to sink it into the deep ocean. So we currently have no idea what the biological effects of this massive food dump into the deep sea might be. And there are people actively looking at how to generate businesses at the moment at growing this seaweed and dropping it into the deep ocean. So just to summarise that very brief tour, the connectivity of the deep sea with the surface ocean really makes it very vulnerable to climate change effects. So don't think climate change is something which only affects shallow water ecosystems like coral reefs it will have a major effect and is having an effect on the deep ocean. The deep ocean, the life in it is very important to the carbon cycle, so we need to think about that in the context of modelling what happens with climate change. And some methods of decarbonising our economies and pulling CO2 out the atmosphere may well have an impact on the deep sea. And finally, of course, deep sea ecosystems are really rich in species, and Geotica has shown you some of that just now, but we've only really scratched the surface in terms of our understanding of life in the deep ocean. And with that, I would like to stop. You can find us at revocean.org and hand over to Jamie.
Well, good morning, everyone. Great pleasure to be here, and thank you for inviting me. I'm going to touch a little bit about the Nippon Foundation JEBCO Seabed 2030 project. Not very long to speak about it. Very happy to take questions later or offline or whenever you see fit. But just touching on the project very briefly. So I'm going to talk about depth, bathymetry, and why it is important. Bathymetry, depth information, affects a whole range of ocean processes. The depth information that we have is used in modelling of the movement of ocean circulation, bodies of water of different densities and different temperatures and how they move across and through our oceans, how they affect the heat engine and the transportation of heat through the oceans and their effect on our polar areas. The same shape of the seabed, that depth information affects the transportation of pollution, and of course also affects the strength and path of tsunamis, but much more. So the depth information is part of that 3D reference frame, and we heard in the film that you wouldn't build your house on an area that you had not surveyed, that you didn't know what was beneath that house. Well, I'm going to touch on why we need to do more about mapping our oceans. But that depth information, I've touched on some of the effects and the implications here, but of course it affects so much more: the movement of tides, the ability to predict and to look at coastal erosion, delineation of ecosystems and how we protect those and how we demark those in the ocean space. So what is Seabed 2030? Well, it's a collaboration between the Nippon Foundation of Japan and JEBCO, and let's just park that acronym for a moment. But it's designed to inspire, and the key word there, inspire, the complete mapping of our world ocean floor, and to deliver that map by the year 2030 and make it freely available to all. The project's life began in 2016 at a conference in Monaco. Year one of the project, and the project was launched in 2017 at the World Ocean Conference. And this year we've been endorsed as one of the first actions of the UN Decade of Ocean Science. So I talked about the acronym JEBCO, and I'm sorry about this busy slide, but just to explain what JEBCO is. JEBCO is the acronym for the General Bathymetric Chart of the Oceans. And it's a program that's been in existence since 1903 and is run under the auspices of the International Hydrographic Organization based in Monaco and the Intergovernmental Oceanographic Commission of UNESCO based in Paris. So a truly international, intergovernmental program. But it's largely been run to date by a group of volunteers, so people have come together to help map the ocean. They do that in their spare time, they do that alongside their day jobs and their other research. So Seabed 2030 was designed as an accelerator to fast-track JEBCO's aim of making sure that bathymetric depth information was available to all who need it. Bathymetry, depth information, is a golden thread that runs through all those decade challenges that are up there. There is a need to have that 3D reference frame to be able to engage in science, engage in mitigations, pollutants, ecosystems, food, ocean economy, and therefore key in helping map our ocean and key in helping those decade outcomes. So just coming back to Glasgow for a moment, and the red spot, the red circles here are where we're sitting today. Easy to pick up a map from the internet. We know we use these in our everyday lives. People are very familiar with land terrain, and our surface, the dry bits of the Earth, are pretty well mapped, as indeed are the dry bits of the Moon and Mars and beyond. Not so easy when we come to mapping our oceans because of physics. So we need to rely on sonar, amplification of sound through the water to measure that depth. So we're moving away from those electromagnetic optical systems. So we need to put sonar systems onto the hulls of vessels, be they traditional crewed ships or remotely operated vessels. And that takes time, it's a slow process, and the whole procedure takes a lot of effort and a lot of time. We have a paucity of information at sea. These are some examples. You can see track lines from ships, where ships have gathered depth information, but the bits in between are inadequately mapped. There's no information in a lot of those areas, and that becomes more and more acute as you move into the more remote parts of the world's oceans. So progress so far. The Seabed 2030 project has now delivered a map that was published in June of this year, depicting 20.6% of the world's ocean floor mapped. But what that means is we've still got 4/5 of the world's ocean floor still to map, 287 million square kilometers, twice the size of the surface of Mars, and we need to get the job done if we are going to be able to provide that geospatial, that three-dimensional reference frame for a lot of all the other science that we've heard about today and so much more. So to do that, we need, and this is where the INSPIRE comes in, we need to inspire governments, industry, academia, and private citizens to go out and help us gather that bathymetric, that depth information. And the little graphic here, the blue shading shows where we were when the project started, the depth information that's gathered in our world's oceans. The orange is what we've added between start of the project and publication of the map this year. And the grey bits of the ocean are simply those bits where we have no information. So enough from me. Thank you for listening, and happy to join the panel and take questions. Thank you.
Thank you so much, Jamie and Alex and Jyotika. I think there's a lot of commonality between what all of you do, and really it's better understanding of the ocean, whether it's biodiversity or mapping or exploration. It's all about understanding this area that we don't know a lot about. So what do we lose if we don't know what's in the deep sea? And maybe you can each talk a little bit more about what we're gaining from this information that we're collecting. Jyotika, you want to start?
Well, I'll just say, I mean, we've already heard from Jyotika that you know, the discovery from the Falkor of a 500-metre seamount in the Great Barrier Reef, we didn't know it was there. That is something to add to the map. But actually, it's something that, of course, allows further exploration of all the ecosystems that surround that. So simply going out there and mapping the ocean in many respects as a reconnaissance tool to allow people to focus in on that science and that further discovery is pretty fundamental in my view.
I'm just going to add to that. Actually, the mapping of that area, and we're partners with Seabed 2030, so any maps that we collect go into that general database. But the mapping of that area, the last time a reef was discovered was about 120 years ago. And so it will now redefine the shipping lanes and the navigation. That's what a map also provides, is that we know where ships can go and can't go and not damage anywhere. Until then, it was kind of a blank spot. And in improving the shipping traffic, you actually also impact the carbon because you can have more efficient shipping routes. So I think a map is important. So I would also add, though, the discovery, the exploration of the deep sea, the understanding of the deep sea, in addition to the mapping. I think if we don't do it, we actually don't know what planet we're living on. The ocean covers 71% of our planet's surface, and we have some idea of what's on land. We can get medicines, we can get materials, we see these new amazing creatures down there, but that's only a third of where we live. The biodiversity, everything we know is a fraction of what's on this planet. The ocean has 95% of the living space on this planet. So if you take every single thing you know about every continent, that's 5% of what's on this planet. That is how little we know.
Absolutely. I mean, following on from Jamie's comment in terms of seabed mapping, essentially where you have topography in the ocean, that is where you get the hotspots in terms of biodiversity. So seamounts, canyons, ridges, trenches, these are areas where you have real hotspots in terms of biodiversity. So lots of species or species which are highly endemic, in other words, they're not found anywhere else, to those particular spots. And I think what we lose when we don't understand what's in the ocean is actually an understanding of how the ocean is functioning in the context of the broader system of the planet that we live on. And I showed you some examples during the talk of where one single scientific discovery had completely altered our understanding of the way, for example, that, as I said, deep sea fish are interacting with the surface of the ocean and transporting carbon into the deep sea. One single scientific discovery, one paper, changed our idea about how many of those fish there were by more than an order of magnitude, which is quite staggering. Imagine if you sent a scientist out into the plains of Africa and he discovered that there were 10 times more wildebeest there. That would be huge news. And we make these discoveries all the time in the deep sea, and this is why thinking about things like deep ocean mining are quite risky when we have very limited knowledge of some of these systems. And just in the last few years, we've begun to learn much, much more about some of these areas that potentially going to be targeted by these types of activities.
I think you make a really good point there, Alex. Actually, all of those points are excellent, but this is all recent. This is not knowledge that we've had for a very long time. In fact, we didn't even know hydrothermal vents existed until recently. And so the bar of knowledge keeps changing. So what is not being addressed in the research that's taking place right now? And where are those gaps that we need to fill?
Would you like to start?
Yeah, please.
The biggest gap is the space between the surface and the sea floor. That is the place which we know least about. And basically, that's, in some places, nearly 11,000 metres of water column. But in general terms, you're talking about 4,000 or 5,000 metres of water column. Essentially, the deeper you go, the less we know. The water column, the deeper parts of it, so below what we call the twilight zone, 1,000 metres plus, that is probably the least understood and least studied and known part of all ecosystems on Earth. So that's the bit we know least about, but I can tell you every single time we go into the deep ocean, even if it's in places like Rockall off Scotland, we find new species. And when we're working in more remote places, like the Southern Indian Ocean, you know, almost everything we come up with in some areas is new. A great example was back in 2012, the early 2010s, we worked on hydrothermal vents in the Southern Ocean. Every single creature we found on those hydrothermal vents were new to science. Every single one.
Amazing. Jamie, Jyotika, do you have anything you want to add to that?
I will add to that, actually. So more specifically, I think, you know, as our technology improves, we are able to address more and more gaps. But and there's two, and it's a question of scale, really. So on the one hand, we need to cover greater scales. So, for example, SEBA 2030, Jamie said, you know, just over 20% of our seafloor has been mapped to high resolution. We have a long way to go for mapping. But then it's also a question of the other end of the scale, the very, very small, the microbial scale. And that's something that we are, you know, we need technology to really help to address, to understand as well. So Alex said it's from the surface to the seafloor, and I'm going to say it's from the largest to the smallest of scales. But you know, and again, living through the last year and a half, the coronavirus, that has impacted humans in such a huge way, and you can't even see it. So really, it's all ends of that spectrum.
Yeah, and I think I'm going to join forces with both Jyotika and Alex and say that it's not just a deep bit; it's actually across 4/5 of the world's oceans. So we've got a lot to do, a tough challenge, to actually get out there and start discovering more.
Well, I'm glad you brought up the technology piece, because that's an area I'd love to discuss a little bit more. But speaking of technology, for those of you who have joined us late, we are taking questions from the audience, so feel free to put those in through Slido, and maybe our helpful text can put the Slido code up again, so if people wanted to submit questions, they can. Jyotika, you mentioned that technology development can help a lot with this, and it has already in so many ways enabled us to get the information that we have today. What have you seen that has impressed you about the recent development in technology, and how is this making a difference for what we're learning at this point?
Well, one of the things I was involved with was the development of and helping to facilitate the development of remote-controlled and autonomous surface vessels, so essentially a robot at sea for mapping the seafloor, but what it does is deploy and recover another robot at sea that can also map the seafloor and collect data with no humans at sea. So everyone's in mission control. It's kind of like NASA sending robots to other planets. So that kind of technology, and Jamie, you might want to elaborate on this, really will allow us to scale up mapping the seafloor, but at a smaller carbon footprint. So again, I was talking about the large scale. And then very recently on Falcor, on our ROV, we had scientists out testing off the off the coast of Southern California, some very new biological capabilities and sensors, and really amazing stuff there too. So the ability to, again, looking at depths that are in the mid-water column, being able to essentially X-ray things like jellyfish in the wild or other gelatinous creatures in the wild. It's something that's really new. It changes scientists' understanding of these creatures, and also to capture creatures. So a lot of the species that are in the deep sea, we cannot taxonomically identify and work with because they're just too difficult to bring back to the surface. I mean, they live in an environment of no light, very high pressure, and it's really hard to bring them to an environment where we can work with them. So that's where I think also technology is really helping and will help.
Well, I was going to say technology is a huge game changer in ocean mapping. I mean, we've seen, and Jotica touched on it, the ability now for the world to do more with uncrewed or lightly crewed vessels. You can take out some of the danger factor because you can have people sitting in operations rooms ashore, and we did, certainly from a Seabed 2030 perspective, we were invited to participate in an uncrewed transatlantic piece of work that was sponsored by the European Space Agency. We were very kindly offered the use of the sonar system on board the vessel. That vessel was operating in the Atlantic, but it was being run primarily from an ops room on the east coast of the United Kingdom, but actually we had some of our sonar operators dial in from about 12 different countries around the world. And the ability to do that, low carbon footprint, not needing to, and I spent many years at sea, you know, in a ship you always have to come alongside a port somewhere to change crew, to change people, to take provisions on board. You can take all that out and you can reduce your carbon footprint whilst also becoming more and more efficient in going out there and conducting that research and that data gathering.
Yeah, I'd just like to pick up on what Giotica was saying. Some of those siphonophores you saw on the images on the film are so delicate that you literally touch them and they disintegrate. So you can imagine if your normal method of sampling the deep water column is using a net, all you end up with is effectively, at the end of that process, a bucket of nondescript jelly, which is what's left of those organisms that have simply been shredded and gone through the net. So we're particularly interested in developments in what's called environmental DNA or environmental metagenomics, where we can actually sample the traces of DNA left in the water by these organisms and start to use that to pick apart the diversity of life living in these very, very poorly sampled environments. And in fact, that's a way that a lot of the recent work on these deep sea mining or potential mining areas has been done, by sampling environmental DNA. The big challenge we've got is that we can sample this DNA and we can figure out that we've got various organisms in the sample, but we can't actually attribute those DNA sequences to actual organisms. So we've got a big job over the next 10 years or so to actually start populating our information libraries to allow these tools to be used to our maximum benefit.
The other important thing about eDNA and using robotics is that it's allowed us to selectively sample, which means we're not using giant trawling anymore to understand the ecosystem. So we are creating less impact while being able to learn more. And before we move off the technology subject, because we have some questions that have come in I want to address, but one thing I'm surprised that hasn't been mentioned is AI and the ability to crowdsource information. I was wondering, maybe Jyotika, if you could comment on that.
Sure. So I think, we are walking down, not just for the ocean, but in many different sectors, using machine learning and artificial intelligence. So I think what we're heading towards is a space where we will have more automatic machine recognition of creatures. So building on what Alex said, getting that database in place, knowing what they look like, it will really help us to facilitate that. But the other area of technology we've not mentioned is augmented reality and virtual reality. And that's, of course, big in the gaming and movie world. But as our cameras improve and as our capabilities to see what's down there changes, we can bring the experience of the deep sea to audiences in completely different ways, really immersive. You know, at some point, and I showed this at a talk last week as well, you know, you could have an avatar, which is a robot, and you're wearing your AR or your VR, your haptic suit, and you can go for a walk in a coral park, a coral sea park, and sit on the bench and watch the fish swim by instead of going for a walk in a normal park and watching birds. So I think our interaction and our ability to experience and understand the deep sea is changing, and I think we really critically need that to address our health and well-being on the surface of this planet.
Excellent. So I'd like to take some questions from the audience now. We have quite a few coming in. Thank you for those. The first one's an anonymous question, but it's, as the largest habitable space on life, let me start again. As the largest habitable space for life on Earth, are the oceans and their role in climate change being recognized and valued by the countries meeting here at COP26? Anyone want to take that?
Well, I guess I can have a stab. Certainly in climate negotiations of the past, the ocean has not been recognised for its role in terms of taking up carbon dioxide, so its role in mitigating the effects of our emissions, but also actually the impacts of climate change on the oceans, which are, as I said at the beginning, potentially really catastrophic. And the deep ocean is no exception. We've done work in the deep sea in the Western Atlantic that's shown, you know, a change of 1 degree C in water temperature alters biomass by 30%. So we lose 30% of the biomass of the life that's living on the sea floor. So certainly in the past that's been the case. I would suggest that it probably is still the case to some extent, although the ocean has been recognised more and more. Certainly in the IPCC reports, we've had the IPCC special report on the oceans and cryosphere, for example, which and that of course feeds into these negotiations. So the ocean is gaining more and more recognition, certainly, but is probably not there yet in terms of its importance.
Yeah, I think, you know, Alex has touched on some of the key areas there. I think one of the things that people are starting to focus on are the impacts of global sea level rise and how that's going to affect people living, working, operating in those marginal zones that will be inundated. And I think it's a case of, you know, sea level rise will happen. It's how we adapt to it, how we mitigate some of those effects. And I think that's something that I hope will be discussed this week.
And I think, just to add to what Alex was saying, I think the ocean is gaining ground, or gaining water, I suppose. But I think part of that is also, this is the first year of the UN Decade of Ocean Science for the Sustainable Development Goals. So the UN has recognized that the ocean is important. It's the science. We need to know what's happening for all of the goals to achieve those 2030 targets. So the hope is that it will have more of a role in the conversations ahead.
This might be also a good time to address the fact that there are several global campaigns happening, which you mentioned in the beginning, between Seabed 2030 and the UN Decade and the 30 by 30 campaign. What is the impact of these decadal campaigns and working globally? Do you think that's creating more cohesion and bringing people together?
I think certainly from a Seabed 2030 perspective, we are seeing a huge interest. There can always be more interest, so I hope the message will get out there. But lots of people, lots of organisations saying, how can we help? How can we join forces to gather data to support Seabed 2030? And we're seeing that across all aspects of society, government, academia, industry, and citizens. And I think that sort of touches on one of the questions that was asked earlier about citizen science. All those of you who go to sea for pleasure or for work, there is the ability to gather information, and you can do that in parallel to your day-to-day activities as non-delaying. And certainly from a very parochial gathering depth information perspective, we encourage people to switch on their voyage data recorders, to embark a small 5, 6, 7 centimetre data logger for a few $100s, and get out there and gather data. And I think the UN decade is a good focus on the ocean to get people thinking about that and to get those partnerships going. And certainly we tremendously welcome the partnership with Schmidt Ocean Institute and also with Rev Ocean and many others.
Right. Well, I'll move on to the next question on that as well. There's a question here about how your work has been negatively impacted by climate change. For example, visiting remote parts of the ocean due to weather changes. Jyotika, would you like to comment on that?
I think our crew can probably comment on that quite well. That's a really good question. Actually, interestingly, we have, of course, to navigate around hurricanes, and the plans change and the schedules change. But interestingly, for tropical storms and cyclones, we still don't know the full picture there as far as what's happening with the changing climate. So, we had a lot of storms in the Atlantic. Some of those were very, very short, very non-event kind of things that we pick up because of improved technologies. However, the Pacific's been unusually quiet, which was not expected when we first walked down that track. So it's still, the jury's a little out on how the storms will impact our operations at sea. So I'm not sure I answered the question really, but yeah.
Excellent. I have a question here for Jamie. What is your most optimistic estimate of how long it will take to map the seabed?
Well, the science, and my scientific colleagues have calculated this, and essentially it's 200 conventional ship years. So one ship fitted with a full depth multi-beam echo sounder would take 200 years of non-stop work to map the seabed. There are more than 100, there are more than 200 multi-beam echo sounders out there being operated at sea. So if we can combine those forces and bring people together to map the ocean, you can expand the number of ships and reduce the time. So it can be done in the remaining 9 years of the decade, but it is a huge global effort to bring those organizations, those ships together to back onto and to use that tech innovation, those uncrewed vessels that we're now seeing more and more of being operated at sea, that can gather a whole range of science and gather depth information.
You're also working with groups outside of the traditional science organizations. We had a question here about whether you're working with shipping companies and if you're looking at shipping routes in tandem with the mapping.
Well, that goes back to the crowdsourcing, and it can be called crowdsourcing, it can be called community sourcing, and that goes very much to the heart of what we're trying to do. We are reaching out to all organizations, and if you're operating at sea and you've got so let's, in an ideal world, we'd be conducting wide area surveys using scientific equipment in bespoke vessels fit for purpose. But we're not there yet, and I think a ship transiting from Liverpool to, let's say, Singapore has the wherewithal to gather us data. It's got an echo sounder, it's got a positioning system, it's got a voyage data recorder. Switch all that on, gather data. Let's break down those barriers. It is not expensive to do. It's non-delaying, but for a little bit of effort, we can start gathering more and more data and crowdsourcing it across the whole of the marine space, be it large merchantmen, be it small pleasure craft.
Excellent. I'm going to pivot here a little bit. We're going to get a little political. I have a bunch of questions about deep sea mining, so Alex, I'm going to target you here. Let's start with this question. What would be the impact of deep sea mining, not just locally, but further afield?
Well, that's a very good question. I mean, you've got to bear in mind that we've not actually done deep sea mining yet anywhere in the deep sea. The other thing that people may not realise is there's at least 3 different types of mineral deposit that people are thinking about mining. So there's the polymetallic nodules on the deep sea floor, so like the ones in the Clarion-Clipperton fracture zone. There's also seabed massive sulfides around hydrothermal vent areas, and then there are what are called cobalt crusts on seamounts. And these occur in different places, and the impacts of mining those different types of deposit are going to be quite different. But in terms of area of effect beyond where the mining takes place, there's a study just published this year which has modelled the effect of the sediment plumes coming from deep sea mining, and they estimated that from a deep sea mining operation taking place over a year, that sediment would disperse up to 1,000 kilometres from the area of mining. Now, of course, that sediment plume spreads out and then settles quite thinly over the seafloor and through the water column. But what you've got to think about then is, well, okay, but what happens if we've got 30 operations out there mining at the same time, and so on. So what we are already gaining understanding about is that some of the far-field effects from deep-sea mining are certainly going to be there. But figuring out what the environmental and biological effects of those sediment plumes is, we haven't got that far yet.
So as people are taking more interest in that, how do we prevent real estate speculation on shared resources because of mapping the ocean floor? So are the maps contributing to some of this mining speculation?
Well, we kind of know where many of these deposits are already. It might come as a surprise to people, but governments and industry have been thinking about deep-sea mining since the 1960s. So people have been out there for 50, 60 years looking for these deposits. So yes, I mean, mapping the seafloor might help us a bit more in terms of figuring out where these types of deposits may be. But, this is the basic information that we need to really understand where life is distributed in the ocean, and really how to undertake a very wide range of other, more sustainable economic activities as well. So that, it's really essential information to have from all sorts of perspectives.
I think I would add to that. I mean, you can go to many bookstores here in Glasgow and you can buy a whole range of different land maps, and you can use those for whatever purpose you wish, whether that is social or whether it's professional. And it's the same with ocean mapping. It's there, it's available, it's free to use, it's free for everybody to use, and therefore, whichever side of the debate you might sit, you at least have a basis on which to inform some of your thought processes and decisions.
Can I just add to that? I think the benefit, though, of having a complete map of the ocean is it allows us to better manage, and not just one industry or one government that has the resources, but for everyone to see what's going on and to better manage the use and exploration, and and just to know what's going on out there. So I think without that, we're kind of operating blindly for the most part.
That's a great point, Judika. let's talk a little bit more about that collaborative work and open sharing of data, because that is becoming more and more prevalent with the information we're collecting. How is that impacting the science that's taking place?
So I'd mentioned the open sharing of data in my comments earlier. I think it's critical that we do that. I think what history has shown us is the more visibility we have, even on land, and what's going on land, the faster we're able to take action, the faster we're able to respond. And the example I used earlier was, the open sharing of data about the coronavirus and its genetic makeup has resulted in vaccines being created faster than any time in human history. So I think with open sharing of data, we speed up our understanding. We need to have the understanding so that we can really put value and identify areas of hotspots of biodiversity, for example, and then we can take action, concrete action, to whether that's protection or whether that's for tourism or for fisheries or whatever it is. But so I really think the open sharing of data is a key component to this.
Yeah, I think one of the really great examples of this has been the work done by Global Fishing Watch recently, where they essentially made public the AIS signatures, the automated identification signatures of vessels around the world, particularly the fishing industry. And that has driven a whole plethora now of publications which have allowed us to gain a much greater understanding of where fishing is going on in the ocean, where illegal activities are going on, how illegal vessels are transferring their catches at sea to transport vessels, and so on. So that has been a really great example of how data transparency is now allowing us to really focus on sorting out problems in terms of fishing sustainability.
I think data sharing is key. Some of the, I mentioned we started at 6%, we're now at 20.6%. Not all, but quite a lot of that data was data that already existed. People had already gathered. It was sitting on servers, it was sitting on shelves, it was sitting in cupboards, and it's encouraging people to free up the data. I didn't go into the detail of Seabed 2030, but we have a series of resolutions depending on the depth that you're operating in, and our best resolution is one depth value in a grid box 100 metres by 100 metres, so around about the size of a European football pitch. So we're not asking organisations to give away state or commercial or academic secrets and confidentialities. We're asking for a pretty low resolution in the great scheme of things bathymetric model. I mentioned reconnaissance tool earlier, and that's key in all this. And it's just encouraging people to say, let's have a look at what we've got. Let's work out what's not sensitive and how we can make that and share that and make it available for everybody.
It's a great question here, and I kind of smiled when I looked at it, because it's a question about funding, which is important, because we need that to be able to better explore and understand our ocean. But the question is, how do we have more funding for space than we do for oceans? And how do we gain more funds for our ocean world? So Jyotika, let's start with you, since this is a topic you address often.
Right, thank you for whoever asked that question. So there's multiple funding mechanisms, of course. We're a philanthropic entity. We're fortunate we have support. But there's government funding, and government funding is dictated by what the voters want, what the voters know. And so at least, in the US, we see a lot more funding going to the space world community than the ocean. And so part of that is engaging with the public in a different way, inspiring people about the ocean the way they're inspired about space, so that they realize the importance of the ocean and what, how critical it is, so that they can talk to their elected leaders and ultimately change that funding stream. So we've been doing some work with an organisation, a partner called Necton, to look at how can we inspire the public with around different aspects of our culture. So fashion, food, sports, and how do we bring the ocean into those arenas so that we can start making that change at a ground level, essentially.
That's a great point. How do we better engage the public in the oceans and make those connections to the deep sea that a lot of people don't see? Maybe each of you could mention a little more about what you do within your own organizations to address that. Jamie, let's start with you.
I think it's getting the message out there through forums such as this, at a strategic scale, with engaging with partners, asking people to spread the word. And of course, the power of social media. There is, and I mentioned, we're part of the UN Decade. We were fortunate enough to be endorsed as one of the early actions, and there is an ocean literacy component to the Decade's work, and I think we need to look at how we factor in our work to that and get the message out there.
It's a really good question, this, because we've seen the effect of programs like Blue Planet 2, for example, which seem to really energise the public, particularly around the plastics issue. And it's something that we grapple with, every day as scientists, how to engage the public and get them interested in, the ocean. I published a book back in 2019 called The Deep. And the interesting thing that I found when I was doing kind of speaking tour, I guess, connected with that book was almost every single session I went to, somebody asked, what can I do to help the ocean? And I think, really giving the public a role, giving people a role and telling them the things that they can do, either to help ocean science or to actually go out there and do something to help conserve the ocean and the life in it, is key to this. What we must avoid at all costs is the total doom message, because if you say, well, the ocean's, dying, we're pouring all sorts of stuff in it, we're stripping fish out the sea, we're now going to mine it, then people do feel hopeless. And when they feel hopeless, they kind of just give up. The problem's just too big for us to deal with. But in fact, even a single individual taking action can have a really big effect on some of these things. So I think that's key to it. And I've been very impressed with some citizen science projects like iNaturalist, where you can take your mobile phone, you can go out into your garden or into the surrounding area you live and take photographs of wildlife. And that's identified by machine intelligence and artificial intelligence, machine learning. And then experts get those data and they kind of, curate it, and then it gets used for science. And people get to see, oh yeah, that thing I saw was an XYZ. So I've been really impressed with that.
I'm just going to pick up on one thing Alex said, back to the question of comparing space and ocean. It's a very great point about, it's not just doom and gloom and a negative message. So a while ago, I worked on this project comparing how does the space community talk about space versus the ocean community. And back then, one of the big differences was the ocean community was a lot more negative compared to the space community. So in the ocean, we're killing all the fish. In the space community, we're out there looking for alien life, which really, we have alien life on this planet. You just look at any of those creatures that were shown. It's incredible, the variety of life that we have. So there are some distinct differences between the two communities and how we discuss our respective topics. But fundamentally, I think you need ocean exploration to do space exploration. a lot of the technologies that are developed for space need tough environments to operate in, and the ocean provides that. And people do test those technologies in the ocean as well.
Excellent. Just to further follow up on the financial question, the investment question. So we've talked a little bit about how we address some of these global issues, but how do you select where you work globally when the ocean is so prevalent everywhere? How do you make those geographical decisions about where to study the ocean?
For biodiversity, that's really quite a tough question, actually. In shallow water, we can identify the gaps in knowledge. But essentially, as I said before, when you go below 1,000 meters, it's pretty much anywhere that has been poorly explored. So, you know, that's a major challenge. And we've been looking at the costs of trying to address that biodiversity sort of data gap. And we've come up with an estimate to make some sort of significant dent on our understanding of global marine biodiversity. You're probably looking at $1 to $2 billion of investment. Now that, no doubt, sounds like a really big number, but I compared it to some space missions, and you know they're coming in at $4.5 billion plus in some cases, and you know, I won't say there's no immediate benefit to humanity from that work, because you know obviously there is, but you know it's really becoming critical that we understand the distribution of life on our own planet. So,
where do you start in the ocean? I think if you ask a group of people who've got an interest in the ocean, you'll get a different answer depending on their area of very specific interest. We're working very closely with one of our partner organisations to try and determine what we're calling a global priority list for seabed mapping. And that is involving a lot of work to reach out to organisations to try and assess their needs, the areas that they seek to operate in, and to try and pull all that together and come out with a sensible mapping prioritisation plan. And arguably, I would say this, but the areas that come out top priority are perhaps the ones that someone else is actually going to do, because there's other science involved in there, and maybe we should, as a project, focus our efforts on the lower priorities initially. But it's a huge challenge, and it's going to be very interesting to see what that piece of work delivers.
Excellent. So we've had actually several questions come in about plastics in the ocean. So I'd like to clump some of these questions so we can talk or address it a little bit about the effects of plastics in the ocean, and maybe specifically the deep sea, and if that's something that each of your organizations is addressing in the work that you do.
Maybe I can start. I mean, we probably published one of the first papers on the discovery of widespread plastics in the deep ocean from work we did in the southwest Indian Ocean back in the late 2000s. And there we were working in one of the most remote parts of the ocean. I mean, 5, 6, 7 days steam from the nearest land at full speed on seamounts lying between Madagascar and the Antarctic. And we found every single sediment sample we took, and many of the animals were contaminated with microplastics. Every single one. So hundreds of particles of plastic on the animals, but also inside them, and so on. And you know, we don't really have a very good idea of what the effects are on individual organisms of that plastic contamination, but also, more to the point, what the effects are on ecosystem function of that plastic contamination. There is some evidence now coming from things like coral reefs showing that high levels of plastic contamination damage the function of reef ecosystems. But our understanding of that in general is very poor.
We also, whenever we sail, we could be in some pristine environment that no one has ever been to before, as you saw in the film. We've never been, no humans have been there before, and there is a piece of plastic, which you also saw in the film. Or a plastic bag, a balloon, so not just micro, but, things that we can pick up with the ROV Sebastian, and we do, and we bring it back and, get rid of it. But basically, the human footprint is ahead of us. There is already a human footprint without humans actually having been there before. It's amazing how widespread this is now.
So that's a great segue. There's been some questions around plastics, around mining, around fishing, around oil spills. The human footprint is around us. What is the biggest threat, in your opinion, to the deep sea? Who wants to start?
That's a good question. Where do we start?
Well, I'll say it from a bit more of a lay perspective, because I'm not a scientist, but I would say not knowing what's out there is the biggest threat, and without that discovery, we don't know what to protect.
I think that's a really good point. We did a report for the high-level panel on sustainable ocean economy recently on biodiversity, and that showed that the biggest threat to biodiversity in general in the ocean at the moment is probably still fishing, but also habitat loss, so habitat destruction through things like coastal development, increasingly climate change. And I would say for the deep ocean, climate change is the biggest threat, because you're seeing something which can fundamentally alter the food supply to the deep ocean. It can alter the oxygen concentration, can change the pH of deep sea water, and all of that has an impact on deep sea life.
I'm just going to go with both of those answers, actually, because I think you covered the two big.
So with that information, or with that understanding, what would be the message that you have for the political leaders here about the ocean and deep sea?
I think that, I've had many conversations with policymakers about climate change, and they've moved from total skepticism to, now wanting a better understanding of what effects climate is having on the ocean. What I would say now is that climate change impact on the ocean is absolutely pervasive. Marine life is on the move everywhere you look in the ocean. It's moving towards the poles if you're in shallow water. We're not so sure of the effects on the deep ocean, but there's certainly a huge signature of climate impact on the ocean, more so, in fact, in some ways than on land. Coral reefs are the most threatened ecosystem on Earth as a result of climate change effects, but also that the ocean has potentially a really big role in terms of climate mitigation as well. And our policymakers really need to look at that in detail and think about what the ocean can do for us in terms of the fight against climate change.
Excellent. Jamie, do you have anything to add to that?
I think one of my messages, and again, very much focusing on Seabed 2030 and mapping the ocean, because we need to provide that 3D reference frame, is for countries to have a look, conduct an inventory of their data holdings, work out what hasn't been released that is still being kept in secret for whatever reasons, and consider how you can release that to help map the ocean, and at the same time to join together to look at how you can combine resources, and let's reduce that 200 ship years by increasing the number of ships and uncrewed platforms that are at sea gathering data. And
just to add, to both of those, I think, for politicians and elected leaders, they do need to pay attention, as Alex just said. marine life is moving forward. So, and that is going to impact fisheries. It's going to impact what we have on our tables. I was at an Oceans and Climate conference last week, and they showed that around the UK, cod is on the move. There was a flippant, it'll be, instead of fish and chips, it'll be squid and chips. But it is going to have an impact as marine life moves and shifts on our economy as well. And so I think that's going to be a key for political leaders to take note of.
Excellent. Jyotika, you mentioned a climate conference last week, and maybe this was addressed. We've had a bunch of questions about carbon sequestration technologies and the deep sea as a sink for carbon. Can you maybe speak to if that was addressed, and if not, maybe each of you could talk a little bit about that?
Yeah, I mean, there's certainly a lot of discussion on, the ocean as a not only being impacted by climate change, but using it to mitigate climate change. And Alex, I think you showed that slide of seaweed being grown and stuff. There's a number of efforts underway. So there's the Blue Climate Initiative. They actually will be announcing on the 5th of November some of their ocean innovation semi-finalists as well, and some of those address this whole issue of how do you get solutions for this problem of climate with the ocean, nature-based solutions. So using kelp, for example, is one of the ideas there. So there's a lot of discussions going on around this, a lot of potential solutions. But I think the point you made, Alex, was we need to know what the longer-term impact is going to be as well of those.
What about some of the other areas that have been discussed today about deep-sea mining or fishing or plastics? Are there other alternatives to those larger issues that you're seeing become more popular with ocean science and with ocean tech solutions?
I mean, these are all very, very complex areas. In terms of deep sea mining, I mean, my main expertise is in deep sea ecology, so that's where a lot of my attention is focused, on the environmental impacts of deep sea mining. But actually, I'm not convinced that the case has been made economically that deep sea mining is the way to go to supply what we need in terms of the renewable energy revolution. One of the justifications I've heard a lot is that mining on land is really terrible, impacts the environment, it affects people's human rights and so on. I think my view there is we've got to clean up our act on land. And at least on land, we can see what's happening directly. It's much more difficult to monitor what's happening with these types of industries 4,000, 5,000, 6,000 meters down, way out in the ocean, beyond the coastline. So I'm not convinced the case has been made for that. I'm not convinced about some of the thinking around environmental regulation of deep sea mining as yet either, because essentially those regulations were starting to be put into place before we started to get our understanding in order in terms of what life lives down there and where it's distributed. So if we were thinking about, for example, set-aside areas now in the Clarion-Clipperton fracture zone, they'd probably look very different to the ones that are currently designated. So, yeah, that's deep sea mining. Maybe I'll hand over to...
Alex is much more of an expert than me in that area, but I think the point you've just made is the case has yet to be made, and I think as humanity we've got to look very closely at what we do need to make sure we remain sustainable, globally?
I think technology will help in a way. So I'm thinking of an example for fisheries. And there's up-and-coming lab-grown fish. So instead of actually going out and fishing, it's being grown in the lab. There's a huge investment in companies like Blue Naloo, $60 million, to get, and you know, apparently it tastes great. And so some of these new technologies, especially biological, you know, capabilities, will really help. So there may be new ways as we move forward, where we don't harm the ocean as much, where we leave it to be, and we have other ways to sustain our livelihoods and the lifestyles that we've become accustomed to.
Yeah, and I'll just add, in terms of the plastic problem, there's a fantastic report that was published recently called Breaking the Plastic Wave. And that report really shows that there's no one single solution to the plastics problem. There's a whole range of things we have to look at, from how we use plastics to what types of plastic material we use. But ultimately, one of the answers to that problem is we've just got to produce and use less of it. So in terms of the current pressure downwards on the oil and gas industry, that is resulting in pressure for oil and gas producers to look at producing more plastic instead, to use that material. That is not something we should be thinking about doing at all, because certainly one of the answers to that problem is just to use less of the stuff.
So, Alex, you've alluded, and actually everyone's talked about this a little bit, about public engagement and messages of hope, and how do you give people something to do to help that's concrete, that's tangible with the deep sea. What would be the message to the audience here today, and how they could get further engaged in better understanding the science of the deep sea and helping to protect it?
Well, I'm a great believer in every little thing helps, and I know that's anathema to some people who campaign against things like climate change and biodiversity loss. But I do believe that people should look at what they do in terms of their everyday lives, and there are many, many things we can do which actually help mitigate against climate change and mitigate against loss of biodiversity and things like overfishing. There are lots of guides out there as to what a sustainable fish to eat and so on. But also people should be thinking about the bigger things. So, there are campaigns out there that people can join. If there's not one that suits your particular interest, then start one yourself. So it's everything from the small things to the big things, and ultimately, to things like who you vote for in terms of your politicians and what you buy off the shelf and so on. So there's a wide range of things. And for the younger members of the audience, come and do marine science. It's just amazing.
Jamie, how about you? How do we get people excited about maps?
Well, I'm going to add to that and say, when you're doing your marine science, switch on your echosounder and map, because actually, as Alex will tell you, you can't do a lot of that if you don't know where you are. But I think it is the bringing together of, spreading the word, engaging people, engaging societies, engaging organisations, and actually the partnerships that come out of that. Because we've seen as a relatively straightforward project the power of the partnerships, and that sort of sum of the parts being greater than the whole is what's helping us drive to our mission. So we need more partnerships, more people driving the right direction, all for the benefit of humanity.
And I would just say, adding to all of that, just remain inspired. It's an amazing place, the ocean. It's a whole new planet. I'm very excited, SEBA 2030, by the end of this decade, we will know what's on this planet for the first time in human history. We will know. And that is just a mind-boggling idea. So the ocean has a lot to offer. I know we talk a lot about the pragmatic side of things and some of the issues, but it is a wondrous place. It truly is.
I'd like to volley off that a little bit in terms of the wondrous place, because I want to take an opportunity to talk about some of the projects that we've been working on to engage the public in the deep sea, and we thought this would be a great platform to do that. One of them is with the World Ocean Observatory this past year, taking some of that incredible footage that we've collected with ROV Sebastian and creating the first virtual aquarium where people can get a closer look and really explore some of these deep sea species that you wouldn't be able to look at in your traditional aquarium because they would not survive. And not only being able to interact and look closer, but to have some real life scenarios that people can explore, such as whale falls or hydrothermal vents, to really inspire with some of this incredible footage. So I'd love to show the first preview we have of this virtual aquarium that will go live in early December. So if we could show that sizzle reel, that would be fantastic. So I hope everyone will get inspired by some of the wonders of the deep sea and help explore that when it comes out in December. You'll be able to access it through schmidtocean.org. And the final example I wanted to give that uses some of this deep sea imagery and inspiring wonder is a partnership that we've recently done with the Australian National Maritime Museum. And they have a new exhibit that's coming out December 1st as part of their celebration of the UN Decade of Ocean Sciences for Sustainable Development. And their exhibit, One Ocean, will allow people to explore not only the deep sea, but all aspects of the ocean, focusing on oceans and climate. And we'll take some of the deep sea species that we found during our Australia campaign in 2020 and 2021 and allow visitors to interact in real time with some of these species using a Pepper's Ghost technology. And so I'd love to show one last sizzle reel of what that exhibit's going to look like. So I think some of the take-homes I've heard today is the use of technology, inspiring wonder, and engaging the public are all things that are very important. I'd love to give our panelists one last opportunity to share any final thoughts that you have about deep sea and some of your hopes for this week at COP. Let's start with you, Jamie.
I think this week is the world's eyes are on what's happening across in the blue zone this week, and I think that's going to be fundamental to our well-being, the preservation of humanity, how we adapt, how we mitigate against climate change, and of course the ocean is a fundamental part of that. So I hope this week will be a realization for all those who maybe haven't quite thought as much about the ocean and how much the ocean matters in our climate than it truly does. So that is my message. Our organisation is a very small part of that, but again, it's that three dimensions that is all important in how we go about our everyday business and how we look into the future. So please think about three dimensions and how you can help.
Yeah, I was looking at some of the headlines in the news this morning, and various headlines about this being the last chance. I actually think it probably is the last chance in terms of doing something